Storage Tanks Incorporated, and today we're going to be talking about compliance for NFPA 22, but more importantly, equivalence and mitigating liability. So a little bit about me. First of all, I am president of Water Storage Tanks. I am also CEO of Specified Water Systems, which is a construction company that specializes in water tank installations. I am an acting principal member of the NFPA 22 committee, and I am on the AWWA Committee 306, a principal member of that as well. Today, I'm going to be approaching this not so much as an owner of a business, but more in my capacity as serving under these committees and educating you on what we need to do to stay compliant as we're reviewing different plans, as we're designing systems, and as we're looking at alternatives that are out there. So the first thing is, I want you to understand what the basic checklist is for NFPA 22. So how many of you have scoured NFPA 22 and understand, I've looked at the standard? A few hands here or there. Any tank can have an anti-vortex event. We're going to cover that, but those aren't really what lead into the equivalency standard. We're going to get into that in a second. But I want you to feel confident when you look at putting together a submittal or reviewing a submittal or inspecting a tank that you understand 22 and what the intent of the standard is. And then, of course, the final thing, we're going to focus on determining what constitutes equivalency. This has been a major hot button in the last few years. A lot of questions have been posed to NFPA. Are these tanks compliant? Will they work? Can I use them as fire tanks? And you go to a lot of people who are fire protection engineers are actually on the committee, and they can't really tell you what constitutes equivalency. So I'm going to focus in on that. The bulletin that you have gets into that in a lot more depth. I can only do so much in a 30-minute presentation, but at the same time, I wanted to give you a resource that you can look at on your own time. So NFPA 22, it's focusing on a lot of different types of tanks. For today's presentation, I'm going to hone in on suction tanks and a few of the connections and fittings that they're going to have. So the practical application of 22, one of the things that I get a lot of questions on, is this only for rural applications? In fact, the majority of our tanks are going in high growth suburban areas. And so areas that they probably have a municipal line, but it's not been upgraded to what it needs to get the flow requirements for that building. Or they have a large line and it doesn't have any pressure. So the AHJ will come in and say, you need on-site water to meet your demands, to meet any event that may happen. These could be wedding venues, they could be breweries, vineyards, anything along these lines. So we have a lot of commercial buildings going in just outside of a major metropolitan center. And that's where you're going to see a lot of 22 tanks going in. They can be used for feeding a fire pump and hence fire sprinklers, but maybe that building isn't large enough to require a sprinkler system. And in those cases, a lot of times the AHJ will have a direct draft system set up to these tanks. So mitigating liability. There's a lot of design professionals out there. Are there any PEs in the audience right now? We've got a couple, thank you. Obviously, when you stamp a submittal or a plan or any of those things, you're taking that liability upon yourself. So we want to make sure that you know what you're looking at, making sure that it's designed properly. The code enforcement officials, the AHJs, also are taking on liability. They do, in most jurisdictions, they are not protected by sovereign immunity. So they can be sued for not reviewing a plan appropriately or adequately and letting something get through. And these are just some examples that a quick internet search revealed. In some cases up to $3 million per occurrence can be an individual can sue the fire marshal, the fire department, and the city. Henry Truman said, prevention through engineering, enforcement, and education. I think it makes a lot of sense. I think this is really something we're talking about here. That's the reason we have the NFPA standards. That's the reason we have SFPE. We are trying to do this better, and we're in speeches like this, it's all about education. And then, who can tell me what this means right here? It's Latin for basically ignorance does not excuse. So just because you're ignorant to the law, ignorant to what the standards are, how it should be done, does not excuse you from being liable. So NFPA 22 covers a lot of different tanks, and there's many, many chapters. A few of them, just for example, welded carbon steel above ground tanks have been around for a long time, proven design, used in petroleum as well as water. They're very proven design, but they have their limitations as well. If they do start corroding on the inside, you're not going to see that until it starts pitting the tank and comes all the way through. So servicing these tanks can be a very arduous process that can take a long time. But again, a good style tank that's been around a long time. After welded steel came smooth-sided, bolted steel tanks, and there's a lot of these out there. Again, in petroleum as well as water, a good proven design, but still have some of the same characteristic flaws that welded steel does over the long term for servicing. You're on fire watch for a long time if that tank needs to be serviced. One of the newer ones to the standard is these style of fiberglass tanks, the square tanks. This one right here is the only one that's technically bolted, and they are in the standard as well. And then you have the kind that I actually sell, and that is a corrugated tank with a liner. And these actually do not have a chapter in the standard as of yet, so they actually fall under the equivalency clause. And this is what we're going to be getting into in a second. A lot of people get nervous about equivalency, but the standard specifically says, excuse me, I guess I don't have that in there. The standard specifically says that it will not limit you to anything that is of new technology. And I've got a slide later on that will discuss that. So we'll come back to this in a minute. So let's get into the basics. Basic NFPA 22. You're going to have an anti-vortex fitting, a roof vent, a ladder with fall arrest, a water level gauge, heating depending on your climate. Typically, they're going to be thicker wall sheets than just a standard irrigation tank or domestic tank, because you're complying to IBC risk category 4, which means it's got a higher factor of safety on it when you look at your structural engineering. You're also going to have a 25-foot live load over the horizontal projection. This is important because you want a safe and serviceable roof. So anti-vortexes, one of the most basic accessories that we add to our tanks. The vortex plate needs to be twice the diameter of the discharge line. It has to be a minimum of 6 inches above the floor. It has to have a long radius elbow to allow for better flow and to prevent friction loss in that pipe. There are a lot of folks who don't understand this, and so you can see that this is a non-compliant anti-vortex. It's got a short radius elbow on it, so this is something to keep in mind. Venting, another very important thing. It seems simple, but this is what can happen to your tank through cavitation if you do not have proper venting. This was as simple as a bag, oh shoot, I hit the wrong button, I'm sorry, as a plastic bag getting over top of that vent, and it completely cavitated the tank. So again, good venting, there's standards in here, and it's listed out right there to have good venting on your tank. A lot in your freezing areas, you need a frost-free vent, and that's specified in the standard. Ladders with fall arrest. Fall arrest doesn't come in until after 24 foot per current OSHA guidelines, but you need an external ladder with fall arrest if you're above 24 foot. A lot of tanks are below that, so you can get away with not having a fall arrest on them. Internal ladders are subjective based on the desire of the AHJ. Some chapters for specific types of tanks still show internal ladders, but not every single one. So what we have found is that some AHJs require them, some do not, and it really is a preference of that jurisdiction. Us personally, this is the ladder that we use. We actually take our ladder and we pull it out of the water. It's on a hinge system, so it's not subjected to corrosion while it's not in use. It only needs to be lowered for servicing and inspection of that tank. And then tanks must have a liquid level indicator. Keep in mind that there's different types that are out there. There's inverse, there's true level. It's important if you're establishing a requirement for a jurisdiction that you try to standardize that, because when a driver shows up to the tank, he wants to see if it's full or not, and an inverse is completely different than a true level. I was talking to somebody the other day who actually said the tanks in their jurisdiction have both styles attached to them, so that the driver can choose which one he wants to look at to determine if it's full or not. Immersion heating. This is required obviously in freeze climates, and the goal is to keep your water temperature above 42 degrees, and that can be done through a combination of insulation and heating. It doesn't have to be an immersion heater. The standard does allow for recirculating systems and whatnot, so there's different things that you can do in order to keep that water above 42 degrees. But if you are in these areas, you also should have an alarm that lets you know when that temperature has dropped below that level. So let's get into evaluating for equivalency. And this is what I was saying earlier, that nothing in the standard is intended to prevent the use of systems, methods, yada yada, basically from new technology being used. It was very interesting in that I think it was 2021, if memory serves me, the NFPA 22 committee had been posed with so many questions about equivalency and quote unquote nefarious companies trying to get tanks in that they didn't believe met the intent of the standard, that they actually put together a subcommittee to come up with a recommendation whether to ban this style of tank. When I found out about that, I was fortunate enough to get on the agenda for their next meeting, present it to them, and they voted based on my presentation that these tanks can meet the intent of the standard under the equivalency clause, but the AHJ needs to take the time to make sure that they're truly providing the documentation, the engineering, and the proof that they are equivalent. I'm on the committee now. I've been working with the committee since then to determine how do we educate everybody on what constitutes equivalency. The technical bulletin that you have gets into that in a lot of depth. I'm going to hit the highlights right now. The main thing to keep in mind is that structural equivalency is different than fire tank design. So if you walk away with nothing else, keep in mind that most engineers, and for those engineers in the room, I hope I don't offend anybody, there's those who are fire protection engineers and those that are structural engineers. There's few that do both. And so usually what I recommend to my AHJs when I'm talking to them is look for two stamps. One that a fire protection engineer or designer has looked at, that they have all the appurtenances, that they meet the volume requirements, all that stuff that we talked about earlier. and two, that a structural engineer has looked at it to make sure that it meets the wind loads, the seismic loads, the live loads, all those other things that are highlighted in the standard and in other supplementary things such as ASCE 7. So structural design, it must be done by a licensed engineer. It must be done in compliance to risk category 4. So if you look at the IBC, it specifically says, I think that I've got a blow up of it here. One more click. Water storage facilities and pump structures required to maintain water pressure for fire suppression. So that makes this tank subject to risk category 4. That means that there's a higher factor of safety applied to the tank than, again, if you were an irrigation tank or tanks used for other purposes. It must be in compliance with ASCE 7 for site-specific coordinates. If you go onto the current ASCE hazard tool, you will see for your specific location how that can change. I mean, just within a few miles, the tank, the wind loads, the seismic loads, and the snow loads can change dramatically, and that impacts the tank. How thick is the steel? How's the roof built? All these things. And so it's really important to get site-specific engineering and then submit that for the equivalency to the AHJ. So just looking at a few different things. Where roofs have a slope of less than 30 degrees, they shall support a uniform weight of 25 pounds on the horizontal projection. I've had folks come up to me and say, hey, we're in a desert or arid environment. We don't need to worry about this. Well, it's not about snow load necessarily. It's about people getting up on that roof for inspection, testing, and service. If they need to get across to service the vent, if they need to get in for an NFPA 25 inspection, it needs to be safe and serviceable. So it's really important that if it's less than 30 degrees, that it meets this requirement. You can look at a roof like this, and you can see with all those rafters and trusses that is a compliant roof. Conversely, you can have a roof that has joists or trusses spread out in a greater distance. And I've actually looked at engineering from some of my competitors, and a lot of times they can only meet a 0 or 5 pound live load. So again, if we're sticking to the standard and what it says, this would be a non-compliant roof. Wind loads. Under Chapter 4, it comes right out and says that it needs to be able to withstand a load or pressure of 30 pounds on the vertical plane. Tanks blow over, especially when they're empty for whatever reason. This is not just water, but this has been proven out in the petroleum market as well as the water market. Tanks can collapse and get blown down the street. So it's really important that they are engineered properly and anchored down properly for these loads that you may see. Earthquake and seismic. This goes misunderstood by a lot of folks because it's not just in NFPA or even ASCE 7. It ties back to other codes and standards that are out there. But basically, in most seismic zones, you need to have a stretch anchor or an anchor chair, similar to what you see on this welded steel tank here. The idea is that wave comes through, that anchor stretches before the anchor clip tears off of the tank. So it moves with the seismic force or the seismic wave. So this is something, if you're in a seismic zone, California, South America, you're going to want to make sure that these are on your tank. There are conditions that if you have a flat bottom steel tank that you can not have any anchoring, and it would be basically self-supported anchoring, but it has to have a steel bottom in order to do that. And that's a different category that we're not talking about here. So an easy one for compliance is to make sure that you have proper seismic anchors on there, and then each seismic zone could require bigger anchors. That embedment depth, the size of the anchor rod, that's all going to change depending on the seismic conditions. The big one is liners, because nowhere does NFPA specifically talk about liners in a tank. They talk about it in an embankment situation outside, and so I get a lot of questions. What's an equivalent liner? What's equivalent to a spray-on liner, an epoxy liner, a glass line tank? Each AHJ and jurisdiction is going to have to take this on their own, but there's some good references out there. AWWA D102, there's a lot of different things that go in there, but one of them, dry minimum film thickness of at least 25 mils. FM Global is one organization that has looked at this fairly in depth, and a lot of my AHJs use FM Global standard for their equivalency, and that is for scrim reinforced liners. It can't be less than 24 mils thick. And then NFPA Chapter 9 talks about it in embankment supported coated fabric suction tanks, 42 mils, but that's exposed to UV, that's outside. And AWWA D103 in a reservoir says 30 mils. So my personal opinion, 25 mils as a minimum, but again, I leave that to the individual AHJs to take the information we present them and come up with their own determination of what is equivalent to a spray-on epoxy or a glass line tank. So to recap the basic checklist. If you look at the structural design, make sure it is done to risk category 4, and make sure they're looking at the wind loads, the seismic loads, and the live loads. Again, I've seen a lot of packages come through that had a fire protection engineer's stamp on it, did not have a structural engineer's stamp on it. And the fire protection engineer did not exclude the structural design. So I'm not an engineer, but as I understand it, by putting your stamp on that package, you have said, I've accepted the structural design as well. So if that tank fails structurally, even though you didn't calculate the loads, you're still taking on that liability. And for the engineers who are out there, do you disagree with that? Okay, you need to exclude that, right? So that is a very important thing to mitigate your liability, and that's what I'm trying to get across here. Look at the tanks. Look to make sure that they have what they need, that they don't have a short radius elbow on the AV, that there's not insufficient venting. I've looked inside of other tanks. I have seen no anti-vortex when there's supposed to be one. I thought I might have hidden, oh, here we go, right here. This is the slide. I've seen where they did funky things with the anti-vortex, like you see right there. That has short radius elbows, and it's not at all set up like it's supposed to be. This tank in the middle, if you go to the outside, you can see that it has a OS&Y gate valve. You look on the inside, there's no anti-vortex. So this particular one, I reported it to the engineer because I knew the fire protection engineer who designed it, and he had them drain the tank and put an anti-vortex in. But nobody had bothered to look inside of that tank until I was out there. A lot of times you can look just on the outside. If that gate valve is too low to the ground, you know there's not room for a long radius elbow and an anti-vortex plate that's 6 inches off the ground. Sometimes it's as simple as just measuring. Test the tanks. In Travis County, Texas, which is where our offices are located, every time we put in a draft tank, they pull up with the pumper truck, they hook it up, and they run a flow test. They make sure that it's working. So there's nothing wrong with testing the tanks. If it's on a sprinkler system, our sprinkler contractors, they will test those lines. They'll have a recirculating line so that water comes back into the tank. They are testing the tanks constantly. When I'm working with a lot of our AHJs, I'm like, define it. That's all people want. Define what you expect to see when somebody gives you a submittal. Know what you're standardized for your jurisdiction. In this case, Travis County again, where I live, we're going to have a true water level gauge. And we are going, not an inverse. They want to have one style of gauge so they know exactly where the water level's at. They require a sign on there, let them know how much gallons is in there. Pretty straightforward. An indicating gate valve. In Travis County, it's a stores connection. A lot of folks opt for a NH, but we use stores. And they don't want to carry hard hose in the truck, so they require that 20 foot of hard hose is at the tank that they can grab and hook up to their trucks very easily. So today, in my 30-minute presentation, I wanted you to understand the checklist. Hopefully, we went over the basics. Feel confident in your ability to either come up with a design or review a design, and then understand, what does constitute equivalency. So if that does cross your desk, you are able to say, yes, this is an equivalent tank, or no, this doesn't meet the intent of the standard, and maybe we should push back on this one. Thank you for your time. Do you have any questions?